Next, let's talk about reflected cross-site scripting. Reflected cross-site scripting can occur anytime a user sends input up to an application that is then reflected back down to that same user. So if that user were to send in some HTML or JavaScript, that same script would get reflected down. Now, at first glance, this doesn't seem like a very big deal. After all, why would the attacker attack themselves? But it turns out this is just the first step of a larger attack. Let's recreate our previous scenario. We have our attacker here, and we have our victim over here. Keeping in mind again that we could have hundreds, thousands, or even millions of victims. Let's create a little scenario. Let's say that we have a user ID and password prompt. And we type in the user ID Rob, and we type in the password. And unfortunately, we typed in the password incorrectly. And we get an error message that says, sorry, invalid login. Now here's where the problem occurs. Sometimes we do things like this. We say, sorry, Rob, invalid login. This is the mistake. We have the user ID Rob that we sent up, and it's reflected back out as output shortly afterwards. Again, the attacker could just as easily have sent up JavaScript instead of a user ID. So what the attacker does next is to craft up an email. The email will contain a message like the following. Dear customer, we have recently noticed some suspicious activity on your account. Please click on the following link immediately to log in and verify your account credentials. Thank you, Director of Security, Hackers Bank. Have you ever received an email like this? They happen all the time. This is part of a common attack called phishing, in which an attacker sends out millions and millions of emails in the hopes that somebody will be fooled. So that's what we'll do here. The attacker sends the email to the victim, and not everybody will be fooled, but some percentage of people will be. When somebody clicks on the link, it sends our pre-built attack string that contains our JavaScript up to the application, which then reflects it back down to the victim. So we still haven't really identified why we would go through all this trouble. Well, it turns out you can do a lot of things with this. Maybe you could erase the login page and replace it with one that looks exactly like the original login page, but when you click on the submit button, it sends the information to your attacker instead of to the original application. Another possibility is to use JavaScript to retrieve the document.cookie variable. This variable frequently contains sensitive information such as the session identifier. Now we're talking. If your victim can send the session identifier to your attacker, the attacker is then able to log in as the victim, and they will see everything that the victim sees on their screen. Reflected cross-site scripting is a pretty simple problem to fix. It occurs because there's no input validation filter coming into the application. And likewise, there's no output sanitization filter coming back out. By implementing these simple controls, this problem goes away. Let's head over to our Hackers Bank application so we can see a real-world example of this. As we saw on the whiteboard, there are two types of cross-site scripting, reflected and stored. Here we will look at reflected cross-site scripting. This application happens to have an example of this right off of the front page. Let's take a look at the feedback option and we'll see what we mean. This page is intended to send feedback to an administrator at Hackers Bank. Let's try out the functionality. Okay, so we type in the message, this is a test, and click submit. Now here's what we notice. It says your following feedback is successfully posted. This is a test. Now if you remember, this is exactly what we typed in as our feedback. This is a problem. If we go back to our form and instead of typing in a message, let's imagine we type in some HTML. Let's see what happens now. Interesting. Now it shows up in bold letters. Let's go back one more time. This time, let's try some JavaScript. Let's submit some JavaScript. Interesting. So I can send this thing HTML, and I can also send it JavaScript code. And this all happens right from the feedback form of the login page without ever having logged in. Now here's one of the worst case scenarios. I'll send it an alert so it actually pops up my document.cookie variable. This lists all the cookie variables in the browser at this time. Login attempts, role. As you can see, the document.cookie variable clearly contains some sensitive information. In a real-world attack, instead of popping this information up to the screen, this information would have instead been sent over to our attacker.